Now we need an equals method and a hashcode method. All right. So we go to source again, and that's nice. They're in the same menu item. Okay, and select the fields to include in the hashcodes and equals method. I want to include all of them. And insertion point after toString. Let's see, use instance of to compare types. I like using instance of to compare types. I'll show you what that does. Use blocks in if statements. I'm not really sure what that does, so I'm not going to mess with that. I'm just going to generate the hashcode and equals method. Wow, that's a big equals method. Okay, we're going to shorten that up. Let's look at the hash code first. This is the standard way to create hash codes. Hash codes are for if you would like to use this class, this person class, as a key in a map. Also, if you would like a set of person class, you're often going to implement sets with hash tables. So anytime you're going to have to put this stuff in a hash table, you want to make sure your method has a hash code. And hash codes should be relatively unique. You're just returning an integer here, okay? And the integer should be relatively unique. It should have very few collisions. In other words, the same object in general, well, the same object should always give you the same hash code, but two different objects should generally give you two different hash codes. And if they don't, that's called a collision. To avoid that, you do this little thing with prime numbers. And it's easiest to just let Eclipse generate this for you. I like to start with a result of 17. That's the way Joshua Block does it in effective Java. The other thing I'm going to do here is I don't need this birthday equals null thing. Okay, I don't need any of these birthday equals null, email address equals null. What that's doing is it's checking if any of these equals null, and it's making the value 0 if they do. As a matter of fact, if you look up here at the constructor, none of these fields can ever be null. And why is that? Well, I'm already checking if they're null here, so I'm avoiding making any of these fields null to begin with. And then I'm being very careful never to introduce null. And in fact, that's pretty easy here because all these fields are final. Okay, so once they're assigned this non-null value, they are always going to have non-null values, excuse me. All right, so that's not that hard to do. But the automatic code generation in Eclipse does not know that. Doesn't know that these fields are always non-null. So it's doing this thing. I don't need that. And I have to return this final. I have to get rid of that final parentheses when I do this. Okay. Okay, so because I disallowed my fields to be null, we come up with a much nicer hashcode method. Much more readable. So let's see if we can do anything similar for equals. And in fact, actually, let me just clean up a few of these initial first. So this first one is common. If this equals the object you're checking, then obviously those two objects are going to be equal. If the object equals null, then obviously those two objects are going to be equal. I mean, obviously those two objects are going to be false. And here we have if object is not an instance of person, return false. So because of the way the equals method is implemented in object, you have to compare things to just a general object. You can't say public boolean equals and then put person here. I mean, you can, but you're not properly overriding the equals method. All right. So the proper way to override is to put an object in there. So essentially what this line is doing, I'm just going to put it all on one line, is this is saying if the object, if the argument here, that the thing you're comparing is not a person, just go ahead and return false. All right. So if you make it to this next line, then you can put person other equals person object. And what you're doing with this here is you're casting this OBJ to a person type. All right. And you're giving it the name other. And actually, this is just a preference thing here. Looks like Eclipse prefers other here. I actually prefer that. And I'll show you why I prefer that. So I'm just going to go ahead and refactor this by renaming it. And I'm just going to put that in there. And it renames all the others to that. All right. And again, look, it's got these if birthday equals null, then that birthday does not equal null. It has to worry about this null thing, but I don't have to worry about that because I know birthday, I know none of the fields are ever going to equal null. So I can actually significantly simplify this. Okay, if birthday doesn't equal birthday, then return false. Okay, and I'm going to change this just to make it blindingly clear what's happening here. So if this birthday does not equal that birthday, then return false. So basically all the fields have to equal each other for the whole thing to be equal. So if any of the fields don't equal each other, I'm going to return false. And I'm just going to do exactly what I did for birthday for all of the other fields. And I'm going to put this there just to make it perfectly obvious what I'm doing. Let me see here and make sure I'm not messing up here. We've got gender does not equal that gender. Okay, gender doesn't use gender is an enum type, and enum types, for enum types you want to use the equals equals and not equals to check for equality. Okay, so we don't have to worry about the null there, it's kind of built in. And this name, and I'm still going to put this gender. It's kind of annoying when you can't get rid of those things. To get rid of the hints, you just have to hit escape. Sometimes the hints are a little bit annoying. So there's the equals method. Look how much easier that is when you kind of condense things and get rid of those null values.